This is Mrs. Carnes. Today's lesson is going to be talking about the 4 basic postulates of geometry. Before we begin, we want to understand that a postulate is a statement or fact that is assumed to be true without proof. So the 4 postulates that we're going to talk about today are going to be statements that you don't have to prove. They're just given. You just automatically know that they are true even without proof. The reason that these postulates are important to know is because they are going to explain undefined terms. They're also going to help us prove other statements down the road that will need to be proved. Postulate number 1 says, through any 2 points, there is exactly one line. So basically, this postulate is telling us that if we have 2 points, any time that 2 points are given to us, like point A and point B, there's only one line that will exist between those 2 points. That's what the word exactly means. It means one and only one. There's no more than one line that will go through any 2 points. And you can always try producing different lines. So if I take points A and B here, we know that line T is the one line that goes through them. And there's no other way. If I start a line that goes through A, there's no way that it's going to also go through B unless I turn it, and then it's not a straight line anymore. Same thing if I take a line and I start to go through line or point B, it's also not going to go through A until it turns and changes directions, which means it's not a straight line anymore. So postulate 1 is pretty obvious that between any 2 points, there is exactly one line that will exist between them. Postulate number 2 states, if 2 lines intersect, then they will intersect at exactly one point. So there's a couple things that we want to take a look at. First of all, we're talking about 2 lines, and we're talking about 2 lines that intersect. Intersect means that they must touch. So let's go ahead and take a look at 2 lines that touch. So if I have a line here, and I have another line here, we know that these 2 lines intersect because they touch. So if this happens, then the postulate is telling you that they will intersect at exactly one point. There's that word exactly again. It means one and only one, and it means that they will intersect at one point. And so when we take a look at the 2 lines that we've drawn, we know that they will touch at exactly one point, and that point happens to be right here. We could call this point A if we wanted to. We could call this line T and line S. And so we would say line T and line S intersect at point A. And it's the only point that they will intersect at. Now postulate 3 changes gears a little bit. We now are talking about 2 planes. Postulate 3 says if 2 planes intersect, they intersect at exactly one line. So there's a few words that have changed here in this postulate. Let's go ahead and take a look at them. We're now talking about 2 planes. They're still going to intersect. This time though, they're going to intersect at one line. Remember, there's that word exactly again, which means they're going to intersect at only one line. There will not be more than one line that they can touch at. So let's go ahead and take a look at our picture here. We have plane P. Notice that this is plane P. And we have plane Q. This is plane Q. These 2 planes intersect. They do touch. So we know if 2 planes intersect, they will intersect at exactly one line. And the one line that these 2 planes intersect at is this line right here. And so they've labeled this line with the points B and E. And so we could say planes P and Q intersect at line BE. They intersect at line BE. It is the only line that those two planes will intersect at. Now, postulate 4 talks about three non-collinear points. It says through any three non-collinear points, there is exactly one plane. So let's break this postulate down a bit and take a look at some words. It says that we have to have three non-collinear points. And so what we need to remember is this word collinear meant that they were the 3 points that were on the same line, but this says that it's non-collinear. So this basically means 3 points not on a line. 3 points that are not collinear. They are not on the same line. If you can find 3 points that are not on the same line, then you know that there will be exactly one plane that will contain them. So let's take a look at an example. If I choose 3 points on our picture here that are not on the same line, let's go ahead and choose the points A, B, and F. Now we know that the points A, B, and F are non-collinear because there is no way that I could draw a line between all 3 of those points at the exact same time. Now it tells us that if we can choose any 3 points that are non-collinear, then we can find one plane that would exist between them. And in this picture, that one plane would be the front of the box. If I shade this front of the box in, I can clearly see that it does contain all 3 of those points, point A, point B, and point F. Now let's go ahead and take a look at another example. If we chose another 3 non-collinear points, like the points H, C, and B. H, C, and B. Now this one might be a little bit more tricky because you would say, well, it's not the front or the sides or the back or even the top or the bottom of the box that would contain these 3 non-collinear points. And so let me see if I can draw or shade in what this plane might look like. If I wanted it to contain those 3 points, it would be the plane that would go between these. So it's kind of like a plane that would be inside the box at a diagonal, and that plane would contain all 3 of those points. It would also contain the point E, but we were only looking at points H, C, and B. So now you have information about all 4 of the basic postulates in geometry. Please remember that these postulates exist without any proof. We just take them for what they say, and they're going to help you later on when you need to explain more complex statements in geometry.